Scientific method versus scientific thinking. The scientific method is an empirical method of acquiring knowledge that has characterized the development of science since at least the 17th century. People have used the scientific method in many applications and areas of science to gain a better understanding of science and how the world functions. Scientific thinking is that mode of thinking about any scientific subject, content, or problem in which the thinker involves the quality of his or her thinking by skillfully taking charge of the structures inherent in thinking and imposing intellectual standards upon them. So the scientific method follows as such. Firstly, identify a problem. Secondly, research. Do background research. Thirdly, construct a hypothesis. Fourth, do the experiment with independent and dependent variables to test the hypothesis. Fifth, analyze the data and draw a conclusion. Sixth, share your results. But what is the problem of the scientific method? Firstly, it is incredibly linear. This method implies that once we have a conclusion to our hypothesis, the science is once and done, fixed for all. Secondly, the method isn't intuitive. How do we construct a hypothesis if we have no idea of what or should happen? Thirdly, it is focused on getting a conclusion, disregarding if the variable changes. We need a conclusion even if the facts change or the information changes. Fourth, it is focused on the experiment, not trying to control the variability and the change in the experiment. This method wants to look at the experiment, not explain the variable change due to condition and environment. So we want to adapt a scientific method that can make wrong predictions where the experiment can be modified and proven wrong. Because if a model consistently predicts the wrong thing, it can be proven wrong. But if a model predicts right, it is only correct until a variability change proves it's wrong. So we want to adopt scientific thinking, as it supports the argument that if every experiment can be proven true, the phenomenon's hypothesis can be proven in every situation, even with variable change. And we use such process to do so. We observe, explain, and predict. And when we're proven wrong, which we do want to be proven so, we can ask more questions, get more answers, and understand how the phenomenon functions. An example of this was when astronomers first found Uranus in 1791, and astronomers noticed that at different intervals of its orbit, it had travelled too far or not far enough, causing its trajectory to change. But what astronomers predicted planet Pluto was gravitationally pulling Uranus and causing its trajectory to change. But what astronomers found was just the asteroid belt. This failure proved the scientific method didn't fit this experiment, and in the same way, the scientific method should be abandoned and scientific thinking embraced, as it would have addressed the variability change and allowed for conditioning of the hypothesis to fit and explain the recorded data of what the astronomers found.